So hello everyone. My name is Mayukh Haldar and you are listening to Coding Exchange. Okay. So now today is our first day of C programming language, like introduction to C programming language. It is our first day, day one. So let us start the class. Okay. Let us start the class. So first I will make a new folder, Coding Exchange Lectures. I have made this folder beforehand so that you can use this. Okay. Coding Exchange Lectures. And then I will open it in VS Code, show mode options, open with code. Okay. Okay. I think it is done. Yes. So now this I will open my this code. Okay, this PDF basics of C programming day one. Okay, so what is C language? Actually, do you know when was C actually evolved? Like C was evolved by actually it was evolved from three basic languages, that is Algol, BCPL, and B, and it was evolved as the Bell Laboratories by Dennis Ritchie in 1972. Okay. So what is C? C is a popular and versatile programming language used to create software and applications for computers. Now, you know, C is also known as a middle level programming language. No, so why it is known as a middle level programming language? Actually, level like if it is a high level language, it means there is higher degree of abstraction, and if it is low level language, it means there is a lower degree of abstraction. Now, what is degree of abstraction? It is the degree to which the system level and memory level details are hidden from the user. Like in Python is a high level programming language. You cannot directly access the memory. But in C level programming language, which is a middle level language, it has the features of both high level and low level programming languages. Like you can access memory through pointers. Okay, in C programming language. But in Python, it is not possible. So you use something else known as classes. Also, you can use them, but in C programming language, you can directly use pointers for accessing in memory. So C is also known as a middle level programming language because it has the features of both a low level programming language as well as a high level programming language. Okay. Like we can write high level code in C as well as low level code in C. So now what are the examples of low level programming languages? Like assembly language. It is a low level programming language, but high level programming languages are like Python, Java. These are high level programming languages, and middle level languages are C. Okay. So it is known for its simplicity because it is simple to write than assembly code, and because of its power, because you can also write assembly code in C since it supports low level language code also. In C you write instructions that a computer can understand. Now we will also here explore how actually a program in C functions internally. Okay, so I will tell you that also. And so in C you write instructions that a computer can understand, allowing you to control its behavior and perform various tasks. Okay. It's a great language for beginners to learn the fundamentals of programming. Like it is not user friendly, but it actually helps in understanding the fundamentals of programming, and it helps to build the logic building. Like it helps in logic building and in problem solving skills. It improves the problem solving skills of the beginners. Okay, I will teach you everything from the beginning to from the scratch to the advanced topics. Okay. So now let's write our first C program. So what will I do in VS Code? I will go here. It is the file explorer. Okay. And then I will click on this. This is actually a new file, and then I will write the name of the first C program, 1.c. Okay, 1.c. I'll close this file explorer. Okay. So now I will write hash include stdio.h, my first line of the C program. Int main. I will explain it all. Okay, line by line. Int main, then return 0. Okay, let me write it here. First second bracket, opening second bracket, and closing second bracket, then return 0. Okay. Now instead of writing this, I could have also written in a different way. Like I could have written like this. So this is the magic of VS Code. Okay. See, this is the magic of VS Code. Like BOI enter, like C. It already gets written for you at one click. Okay. So this is the magic of VS Code. Now you can also write it like this, but for that you need to go here, settings. Okay, wait. Settings, and then here, no, not settings, oh my god, settings, and then you have to go user snippets. Okay, and then c.json. You have to search here c.json. Okay, and then actually I've written this here, but I can show you by writing one for UIs. Okay, I'll comment this out, and I will uncomment this one. You will have this one only. Okay, so from after the example part you will uncomment it. Okay, uncomment it. And for uncommenting it, what I used alt plus control plus forward slash. Okay, like see, control plus forward slash comment, toggle commenting, control plus forward slash uncomment. Okay, so what will I write here? I will write the prefix first. Okay, what is the prefix? Actually, they will print the console the whole boilerplate code. Okay, use a snippet actually. So it will print the snippet to the console. Okay, so what is this prefix part? Okay, the prefix part is nothing but the prefix which I will write, and then it will automatically find it out. Like it is used for searching the boilerplate code. Like I will write here C boilerplate code. Okay, so if I write BUI, it will find out, like the prefix will find out this first three lines, and it will think it is a boilerplate code. Since for my C programming language, I have not set any other boilerplate code, so it will find out this boilerplate code only. Okay, you can understand it very well. So if I write BUI, it will find out this boilerplate code. Its prefix is BUI. So it's like that. So in the body, what I will write, I will actually write the body. Okay, so in my first line, I will write hash include stdio.h. Okay, wait. Hash include stdio.h, and then I will write int main. Okay, in second line, and then comma, and then I will write again another line. I have to write in strings. So in string, you always have double quotes in Python and in C, in every language. Okay, not in every language, but in most of the languages, use double quote for strings. In Python, you can also use single quotes for strings also. And then first opening second bracket, and then I will write string, and then \c for tab character, and then $1. It is actually for mouse pointer, like where is the mouse pointer, where the cursor will point. So it will point after \t, after the tab space, it will point. Okay, and then I will write int main \t, and then return 0. Okay, and after that, oh my god, one comma is written, my bad. Okay, after that I will write this closing second bracket, and after that the program is over. I think, yes, it is over. And the description will be boilerplate code to write boilerplate code for C programs. Okay, and then I will save it. Okay, I think it is done, right? I think it is more or less done. Yes, it is done, and now I will save it and I will run. But here I'm not saving it because it is already saved. Like I can use this one also for integer main function, and for this one void main function. Okay, so you can use them, but I showed it for you how you can write. Okay, actually this is for the tab space, and this is for the mouse pointer or cursor, and this is again for tab. Okay, this is how we actually write. So now let me undo it because I've already made. So let me undo it. Yes, now it's done. Yes, it is done, I think. Yep, it is already done. So I can use this boilerplate code. I can show you. Okay, like if I use write BUI, it will give this, and if I write VBUI for void, okay, boilerplate VBUI, it will give this. Here we have used int, so I'll use int here. Encoding exchange group, the resources which we have provided, there we have used int. Okay, this PDF, in this PDF we have used int, so I will use int. Okay, and since it is our first program, and since it is our first C program, we will actually write the code line by line instead of using the boilerplate code. Okay, so hash include stdio.h, and then int main, then return 0. This is the basic structure. Okay, and after that we will write this line printf hello world. Okay, printf hello world. Okay, let me do one thing. Write this just the same as written here. So hello world. Okay, I think it is perfectly fine. Okay, so it is done. Okay, now let's run this code. Now wait, first let me see hash include stdio.h first line, int main. Okay, printf. Okay, return 0. All right, and let's close it. Okay, now let's run code. It works perfectly fine. Okay. So now we have to explain how this code runs and what are the functions of this writing these things. Okay. So what is the meaning of hash include this line? Hash include stdio.h. Actually, this has some meaning. This I will not discuss now. I will discuss it later. Like actually, it searches for the header file inside the current directory, inside the I think current directory first, or maybe at last. Like this is a different thing. Actually, it searches for the current directory, like header file inside the current directory, or maybe header file, and then actually. I think if you write this, it searches for in the system directory, like in the system or file directory. But if you write it as this one, like if you write here like this, it will search in the same directory as a source file. Okay, like the source file is in this directory, and this directory it will not find it first. So it will, after that it will search in the system directory. But if you write like this, okay, if you write like this. I need to save it, control plus S, so I can save it. It will search in the system directory. This header file will search for in the system directory. Okay. So what does header file contains? What does a header file contain? Okay. Actually, a header file contains all the declarations of the functions which you have to use or which you have included in the program. Okay. Like if you want to go into the declaration, like can we see the declaration? Yeah. Is no declaration. How? I think maybe there is a problem. Okay, definition there is, but no declaration. Okay, we can see the declaration, I think. Oh, no problem. But actually, declaration of functions are written in header files, and then they are mapped with the definitions in the standard C library using the linker. Okay, using the linker software linker. It links the definitions written in the header file with the actually declarations written in the header file with the definitions in the standard C library. That is the function of the linker. I will actually explain it very well to you. It will be crystal clear. Okay, I will explain it. And after that, we have an int main. Okay, main function is a function which you have to include in every C program. Okay, and there should be only one main function. Otherwise, it will be confused which main to include in the program. Okay, there should be only one main function, but unlimited number of any other functions. And we can use any other function. There can be any number of functions, but main function there should be only one. Okay. It is unique to every C program file, and so it should be only there should be only one main function in every file in every C program. Okay, and this actually we use this first bracket here because it indicates that it main is a function. Okay, and since we are not written anything, it means it does not take any argument in these inside it. Okay, and then we have used this second bracket. That braces we also call the second bracket as braces in programming language terms. So it is the first opening brace, and this is a closing brace. Actually, this marks the beginning of execution of the C program, and it marks the end. Okay. Actually, this function will be end. Actually, this function will be ended when it is returned. Okay. After returning the value from the function, int actually returns 0 to the operating system. Okay, main. So it will return 0 to the operating system, and after that, function will end. Okay. That is the stack call for the function in the memory will be erased. Okay. Again, memory function calls are represented as stacks. So after this execution of the return 0, the stack will be emptied from the memory. Okay. And now what is this printf hello world? Actually, printf is a function for printing anything in the console. So printf hello world. Hello world I've written it as a string inside double quotes. And C language you will use double quotes for strings and single quotes for characters. Okay. So hello world. Okay. Hello world I've written. So printf hello world, and I've written this, and so I've explained you like what these things line by line. Okay, now I will explain the internal functioning or working of a C program, like what happens actually in a C program. So now let us actually delve into the basic internal functioning of a C program. Now let us actually write it as a flow code. Describe it as a flow chart. Okay, flow chart, not as a flow code or zero code. Actually, flow chart. flowchart and pseudocode. I mixed it as a flow code. Okay. So flowchart. Okay, let's draw a shape here. Okay, text box. Let me draw a text box. Draw text box. Let me draw text box here. I think it will be nice. Okay, maybe a little bit here. I'll write internal function of a C program. Internal working a C program. Okay. Internal working of a C program. Let me increase the font size. I think it is fine now. And then I'll show you the flowchart. Okay. So let me copy this. Can I duplicate it? Right? Copy. Can I paste? No, I can't do anything like that. Why? Okay, let me delete this. I need to draw text box again. Oh, this is so tedious. Draw text box. Okay. So first we actually give the source code of the C program. Source code. Okay. So we write the source code. That's enough. Okay. The source code. I think now it is fine. Yes. Source code. We first get the source code. Then again you have to draw, insert, shape. I think shape and then this one. So after this, what we give? Actually, the preprocessor directives are there after the source code. So insert or maybe draw. No, not draw. Insert text box. Draw text box. So here you will get the preprocessor directives. Okay, so it will be a little big. Preprocessor directive. Or preprocessor. Okay, it copies the directives. Actually, it copies the declarations. Okay, copies all the declarations. All the functions used in the included header files. For example, you can consider like it copies the declaration of the printf and scanf function used in the included header file known as str.h, standard input output header file. Okay. Okay. So let me get like this. I think it will be good. I think 14 no 12. Okay, 12 is good. And let me. Okay. Fine. And then we use extended source code. Now it will be known as extended source code after the pre-processing. Okay, takes place. It will be converted to the extended source code. So shapes, this one, and known as extended source code. It will be the extended source code. Okay. Let me increase the size. I think now it is fine. Yes. After this process is known as what? Do you know what this process is known as? This process is known as. Let me show you. Wait. Okay. This is known as pre-processing. Okay. And this is known as pre-processing. Okay. Working of a C program. Okay. So after this pre-processing, it will send to this extended source code will send to the compiler. So let me again insert a shape here. Can I write it here? Okay, let me write it like this. Okay, now it is good. Let me again insert this text box here. Draw text box. It will be the compiler. And what does the compiler do? Can anyone tell? What does the compiler do? It checks for syntax errors. Any possible syntax errors? Okay. Syntax errors. What is happening today? Okay, syntax errors. Checks for any possible syntax errors. Nice. Okay. After this, we will actually use this dot expose. No. Yeah, the check shape. Okay. After this, the compiler actually converts it into machine understandable code. Okay. Object code. Machine understandable object code. So let me draw this text box here. Draw text box. Machine understandable object code. This process known as compilation. Machine understandable object code. Okay. Machine understandable object code is something different. Okay. Okay, simple. Machine understandable object code. This process known as compilation. Recognition as compilation. Let me draw text box. Compilation. Okay. And after this, we have the linker software, which is used to actually link the declarations with the definitions. Okay. So insert shape the linker. So draw text box. Yeah, the linker. It actually links. In simple terms, I'm telling you, like it actually does more complex thing, but in simple terms, it links or maps the function declarations. Okay, function declarations in the extended source code, actually, not in the object code. Extended source code present actually it is converted into machine understandable object code, but in the extended source code, we use the function declarations, right? Like this in this point, extended source code, function declarations are included, right? So it links and maps the function declarations in the extended source code to the function definitions present in the standard C library. Actually, so what is actually the standard C library? So what is actually the usefulness of this thing? Like if we actually directly included the definitions, it would have been much bigger source code, right? You have taken much bigger space. So what we do, we actually just include the definitions of the header files, definition of the functions of the functions present in the standard C library, and then we map the function declarations or headers with the function definitions. So it is much faster and much more efficient, and the extended source contains less code because we just include the function declarations, not the definitions. Okay. And so after this, the linker converts this into executable object code. It is machine understandable object code, and then it is converted into executable object code. Okay, wait. Let me actually use shape. Okay. So what is happening? Oh, sorry, I clicked it twice. So machine understandable object code. Okay. So after this, it will be converted into. Wait, go. Okay. Yeah. Converted into executable object code. Okay, executable object code. Okay, and it's after checking for possible logical and actually what kind of errors? How many errors are there? Logical and data errors. How many data errors? Yes, data errors. Okay, and after this step is known as linking, and after this executable object code, we do execution. Okay, so it is the same process. So here it will be execution of the final program. Okay, so this is the internal working of a C program, or internal functioning of a C program. This step is known as execution. And so let me increase the font size. Okay. So this is the internal working of a C program. Source code to preprocessor, like copies of the declarations of the functions using the included header files, and then pre-processing happens. Extended source code. Compiler checks for any possible syntax errors. Compilation process. Our machine understands the object code, and then links or maps the function declarations in the extended source code, like in this extended source code, to the function definitions present in the standard C library. Okay, standard C library, and then it converted executable object code after checking for possible logical and data errors, and then it is known as execution. Okay, so this is the internal working of a C program. So now let's get back to our folder and PDF file. Okay, and our code. So this we understood line by line everything, like what is this str.h standard input output header file. Then int main we have understood it very well. Then printf also we have understood. Now let's check the output. Okay, let's check the output now. Okay, we have checked this output. See, we have not written return 0, but generally we give return 0 because it is a good practice. Okay, return 0 should be given since it is int function, and it expects the return type of int. If we don't give also, nowadays modern compilers don't give any error, don't raise any error, but generally it is a good practice to give return 0. Okay, for an int function, int type return function, int return type function. Okay, that's same. So let's do some changes now. Okay, let's do some changes. So let me name it the second function. So second file 2.c. Sorry, 2.c. So what can I write? Hash include? No. BOIs. Okay, boilerplate. So we will write printf. This is coding exchange, the best coding community. Okay, the coding exchange. So this is coding exchange. Okay. So this is coding exchange. Now let us run this code. Run code. Oh my god, it printed. Oh my god, the output is there in this console. That's great. This is coding exchange. Okay. Test it out with your name within this code. Okay, let me test my name within this printf. Right now my name okay, is Mayukh Haldar. Okay. So this is it. Now let's run this. Now you will see one thing, that it prints just after this exclamation mark, though I wrote it in next line, new line. Okay, here I wrote it in new line, but here it didn't show this on a new line. Actually it printed on the same line. Now why this is happening? Because this is happening because in C it doesn't consider that there is not a new line added after this. Now you have to mention explicitly a new line after this. So for that we write \n. This is an escape sequence or escape character for a new line character. Here also we shall write a \n. That is a good practice. And write run code. So it is my coding exchange. My name is Mayukh Haldar. Okay. So it's printed here. So now we are done with printing one line. Let's print another line. So we have printed another line. Okay. Now escape sequences. In C programming, escape sequences are like special codes you can use to tell the computer to do specific things with characters in your text. Okay. So here are some examples. Now let's try out those examples here. Okay. So escape sequences, a new file. 3.c. Here I'll do escape sequence. Now what I did here, escape sequence. Now I will explain this here also. Escape sequences. So for commenting, you can use control plus // control plus / or toggling comments. Okay. And for multi-line comments in C we use this. Wait, I'm showing you. We use / then start, and this is a multi-line comment. Like, wait, I'm showing you. This is a multi-line comment. Okay. You can write anything. This is multi-line comment. Okay, that's it. This is a multi-line comment. Okay. So let's write the first code here for escape sequences. Let me write it here also. Escape sequences. Okay. Escape sequences. Write my first code. Okay, so what shall I write here? In C programming. Okay, I've written here. Okay, that's not it. Nothing here. So let's write this first. Printf. We'll first write new line. Okay. This is the first line. \n. Alt plus Z for toggling word wrap. In VS Code, this is the function. Not a function, this is a shortcut, a keyboard shortcut. Not a shortcut, yes, shortcut. So you can see it here. Settings, command palette, word wrap. See, wait. Toggle word wrap, alt plus, that is my default setting. Okay. So this is the first line, printf. This is the second line. Okay. Wait. So this is the second line. Okay. We wrote out both the lines. Okay. Now let's run code. And this is the escape sequence of new line character. This is the second line. Okay. So now if I give, like, let's say put a single quote inside a word. Okay. Now let's see the tab. Now if I give here tab \t, let's see what happens. So this is happening actually 8 spaces, right? I think here tab is set as 8 spaces. I don't know why, but generally tab is for 4 spaces, right? Let me see it once here. \n, yes, it is working fine. So I use tab. I think here tab is set to 8 spaces. That's not right. Not a problem, not a big issue. 1, 2, 3, 4, 6, 7, 8. Nice. Not a big problem. Okay. Now, as the tab is a big space, let's put a single quote inside a word. Okay. Now let's put a single quote inside a word. Okay. Single quote / single quote. My name is Mayukh / single quote. Now let's run this, and then \n. Good practice. This is the first line, this is the second line, my name is Mayukh. It's inside single quotes. So now let's write inside double quotes. Control D for copying the same line. You can go here, keyboard shortcuts, then copy lines down. And for it, it's Control D, okay? So I use keyboard shortcut, Control D for copying line down, and then I change this one. Double quote, okay? My name is Mayukh. If I run this, it will print inside, yes, double quotes. My name is Mayukh. So that's done. Now if I want to give a backslash, I Control D and then here backslash. Let's see. Backslash. Let's see, guys. What happens? Yes, it's done. My name is Mayukh. So if you write printf hello / in word, it will show hello and then new line, then world. Okay. Now let's move on to the next line and move a little distance away, like we do while starting new paragraphs. Right. Tab 4 pieces. Okay. So data types in C. Now we will start with data types in C. Okay, data types. So what are data types? The actual types have labels, which actually indicates what kind of manipulations or function operations we can do with this type of data. Okay. So it will be 4.c, right? So data types are categories or labels that tell the computer how to interpret and work with different kinds of information in a program. Some common data types are integer. Okay, so let's see bi int, then a. What did I do here? Actually, I am declaring a variable of type int and name a, and it is only a declaration. Now we can also initialize the variable. So let me show you one thing. Wait, int a. It's a inline comment, inline single line comment. It is known as declaration of variables. Declaration of variable of type int. Wait, word wrap type int. Okay, and in b is equals to 2, it is nothing but declaration. Wait, writing it. And initialization. Wait, of a variable of type int at the same time. Like I am declaring and initializing at the same time. Okay. So now we can just initialize a with 3, and then I can write int sum is equals to initialize and declare both at the same time a plus b. I use an operator here. This is another mathematical operator plus. Okay, arithmetic operator plus. Now we use printf, like print this to the console. Printf function. Printf, then you have to give the format specifier for the integer, which is %d. Okay, that's nice. And then for integer sum, we will write sum. And then this is for terminating the line. We have to use semicolon in C, not in Python. Python, there's nothing used for terminating lines, but here you use semicolon after each line, after every logical logical line. Okay, so this is the terminator, and so now let's write run code. So it is 5. Okay, so sum is equals to 3 plus 2, a plus b, and that is equals to 5. So that is about the int data type. Now let's go to the float data type. Now we can do one thing. We can check the size occupied by integer variable printf in memory, percentage d. Then we can write backslash n to print the next output in a new line. Size of operator. It checks. It actually gives us number of bytes of size of number of bytes of memory allocated for that variable. Okay, integer variable size of int. Also we can write a. It will be same like I'm showing you. Size of int it will be 4, and if you write a also it will be 4 because it is a type of int. A is a variable of type int. 4. Yes, I know. Because both will work. I will give int for generalization. So now let us declare something of float type. Float c is equals to 3.14. Now we cannot define again a because a is already defined once with 3 and integer. So we cannot again define a, like if we give a, it will say multiple definition error. Okay, and initialization is also known as definition. Okay, and declaration is something else, and initialization is also known as definition of variable. So d is equals to 4.14, nothing, not wrong. All right. So now if you write printf, what will be the format specifier for actually? Wait. Format specifier for float. It will be percentage f, simple. Then it will be c plus t or c minus t, anything we can write, but I will always go with plus, so plus, not minus. Okay, so I think for expression here for new line printing after this output 7.28 and then 4 zeros. Actually it actually displays up to 6 decimal places after. Okay, so if I want up to 2 decimal places, what I will do, percentage 0.2. Okay, after percentage I will write 0.2, like dot 2. After decimal point only 2 places. Okay, after decimal point only 2 places are displayed. After if we write dot 2f, okay, 0.2f, we write 0.3, it will display 3 places. Simple, as simple as that. Nice. And after that you will check the size of size of float percentage. See, what I did, Control D for copy line down, and then Alt plus down arrow for shifting it up down. Okay, shifting the sentence down, I used Alt plus down arrow. Okay, so run code 4, like in my compiler, and the compiler in this computer, not my compiler, my compiler, actually in this, the compiler in this computer allocates 4 bytes of memory for int, and now if I use float, I think it will also be float 4 because in this compiler it is 4. Yes, it is 4. Okay. So now it is 4, c plus t. Okay, so now let me define for double. It is done. Double will be same. Okay, I can show you double. It will be 8. Size of double will be 8, but operations are same, only that it has a higher precision. Okay, because of its higher size, it will have a higher precision. Like double e is equals to 4.2 and f is equals to 6.8. Printf percentage lf. Okay, percentage lf for double, and then what is the character name, variable name? E plus f. Okay, e plus f backslash n. Let me run this. Yes, 11.00. Okay, and that's it. But I don't want the 0. So what I will do here, guys, point dot 0 or 0.0. Now let's see, 11. Nice. I don't want the 0, so I gave 11. So after this I will take the size of double. Let me say the size of double. It will be size of double. Okay, so let me see the size of double. It will be 8. I think 8 bytes. Yes, size of double 8 bytes. So double is done. Now let's move on to the short or character. Character is simple. For character we write c is equals to a. So printf format specified character is percentage c, then comma, you will write c backslash n. Okay, Now one interesting thing is, right, where I will show you. Okay, C is already defined, so I can't use C. So multiple definition error will arise, so I will use G. Okay. Now it is working. Percentage C, sorry, G. Okay. Debugging the code. But if I write percentage D here instead of percentage C, you know what will happen? It will print the ASCII value of G. 65. Oh, sorry, A. Yes, G means A, so it will be 65. And if it is capital Z, it will be 90, actually 90. And if it is small a, it will be 97. And if it is small z, it will be 122. Okay, like I can show you. Small z, it will be 122. What is happening? Sorry. 122. Nice. That's it. ASCII values. Okay. So after this character done, short is similar to integer, just the precision is less and the range is less. Okay. So for short we write short h equals to minus 123. It will happen now. Minus 12. Okay, minus 12. Printf percentage hi for short, and then we write h. Okay, percentage hi for short, and then we slash n. Never mind. And then run code. Minus 12. Okay, it is printing. Now we can check the size of character also. It is 1 byte, I think. So let's check it. Okay, not a problem. Percentage d backslash n size of char. Okay. Yes, it is 1 byte. Okay, you can see it is 1 byte. And percentage, and now printf percentage d size of, let me see the size of, size of short. Let's see what is the size of short. Okay, it is 2 bytes. Okay, 2 bytes. Integer is 4 bytes and short it is 2 bytes. And now it will long. Okay, long is what? Long it is long int. It is also known as long int. We can write long int also, but we write long hi. Okay, I equals to 1 2 3 4 5 6, and then printf the format specified is percentage ld comma backslash n comma. We will write actually I. Okay, and sorry, yes, it's all right. Let's check it. 2 1 2 3 5 6 because no backslash n here, so it is printing 2 at first. Now I think it will be all right. Yes, 2 and backslash n, then 1 2 3 4 5 6. Now let's see the size of now let's see the size of this long size. It is 4 bytes. Okay, now let's say for long, it is not mentioned here. It is a bigger container. Long is a much bigger container. Its range is after 10 to the minus n to the 12, 18 to 10 to the power 18, and for long it is minus n to the 12 to 10 to the power 12, and for int it is minus n to the 9 to 10 to the power 9. Okay, so it is long j, then j here, and then here long. Okay, long here. Now let's check. It is 4, like not a 4, nothing. Here it is 1 2 3 4 5 6, and then 8 bytes. Okay, that's it. I can make it 7 8 9 also. 7 8 9 because it is very the context 10 to the 18 digits. Okay, like yes, 1 2 3 4 5 6 7 8 9. That's it. So now we can use bool also, but for boolean data type, it is true or false. We need another library, that is library, actually another header file, that is standard bool.h. Standard bool.h. Okay, standard boolean values. That is, now we can use bool flag equals to true. Okay, bool flag equals to true. Printf, then we can write percentage d for render the value of bool, and then we can write what is the flag. Okay, flag. A variable name is flag. Actually, I want to know the variable name. It is flag. Actually, I want to know the variable name and it is flag. Okay. Yes, it's done. That's 1. That means size of bool is data type. Bool data type is 1. No. Actually, true is 1. Okay. And if I write false, it is actually 0. Yes. And if I write minus 123, oh, it will be 1 because any other number except 0 is 1. But if I write 0, it will be 0. Okay, that's it. 0. Okay. So bool is also covered. So these data types are like category. Now we will see the size of. I think it will be size of. Like we use size of also. It will be, I think, 1 byte. I think. Let's see. Yes, 1 byte is the size of Boolean data type. Okay. So these data types are like categories for different kinds of information you can use in your C program. Picking the right category helps you work with the data effectively and accurately. Let's implement it in our program. We already implemented it in this program, so we are not going to implement it anymore. Like you can see this program very well. And now if you want this theme, you can go to this theme of VS Code. It is actually known as shades of purple. Like you can go here, search extensions, shades of purple. Okay, shades of purple. This is the theme which I'm using right now. Shades of purple. Okay. That's a great theme, you know, in VS Code. So you must be wondering what is the %G in printf. It is all a format specifier. That's it. So format specifiers actually are symbols used to display or reach different types of data like numbers or text in a specified format. They tell functions like printf and scanf how to handle and present data. Now what is actually what does actually printf stands for? Formatted print. Like formatted print, like print in formatted way using format specifier. So yeah, that's it. So examples are done. Make simple one test these. We have done. So that's it for today. And this coding actually, this homework you can do it. I think. If you can't do it, I will tell you later. And the video solution will be provided for this homework solution also. Okay? Like for this homework also, we will make some video solution if we get time. Okay, that's a big issue. But otherwise, this is the video for today. I hope you all enjoyed it. That's it from Coding Exchange, and my name is Mayukh Haldar, and you're watching Coding Exchange. Thank you.